Hi and welcome to another Hopper tutorial video. Hopper is a modern semicolon and curly brace language, similar to Java or C#. It has a garbage collection, but it doesn't have objects. It's been designed to work well on a small device like a microcontroller or an 8-bit CPU like a 6502. The entire repo of all the source code of Hopper is on GitHub, and I'll put a link in the description below. This tutorial is about navigating in the IDE, in the integrated development environment. It's got a full editor, and then this editor is written in Hopper. The toolchain of Hopper is made up of a few different parts. So it's got a preprocessor, the compiler, optimizer, code generation, and then a disassembler as well. So the entire source tree is about 80,000 lines of Hopper source. So when working on a project that's large, like one of the parts of the toolchain, in this case I've opened the preprocessor, navigating the file, navigating the project would be tedious if it wasn't for the tools that are available in this editor. And the tools for navigating in this editor are different to other editors. In the top right, you can see your project name. That's your master file. The way it knows which files to include in your project is via all the users statements. So there is no project file or make file. It just figures it out by parsing your source code and finding out you decided to use the system unit. So if I double click on this path here, it'll take me to the system unit, and the system unit included a lot more units. So it knows these are in your project as well. And up at the right, the left path shows us we're in the system unit. The right path is our project. So if I double click on project, I'll go back to it. So I can quickly switch between them. Another thing to notice is if I modify the source code, put some lines in, the path changes to red. So, and then, file save is available. There's shortcuts on the menus, but you can just press Control S to save, or I can undo that change. And once I've undone the changes, which I could have done with Control Z as well, it's now green again, saying it doesn't need to be saved. Okay. Let's go back to, let's drill down one deeper. We'll go to the list unit. So this is the definition of the list type, of the methods that are available on the list type. So in the list unit. Right. Now, let's say I want to go back up the tree. I don't want to go back to the main file. I want to go back to the previous file I was in. Well, Control backspace is a back. So it takes me back one. And it puts the cursor where I was in that file. And then if I Control backspace again, it'll take me to the top, right? So we can do that again. Another example of that, we'll go into directives. And from directives, we'll go to symbols. And from there, we'll go to library calls. And now I want to go back. So it's back to symbols. Cursor is right next to the thing where I clicked. Back again, cursor is next to what I clicked on, and then back to the top of the pile again. So the first lesson about navigation is you can navigate by clicking on the user's paths. You can navigate by clicking to go back by clicking on this path over here. Another good way to navigate, if I put a syntax error in here, and then F7 to build. It's busy pre-processing, and now it's compiling, and it hit an error. If you look at the bottom of the screen, keyword or identifier expected, and it tells me where the error is. It knows it's on line 3, and if I double click here, it'll take me to that line. So you can double click on the error messages to also navigate. And if I go back from there, I was at the top of the heap already. So, but you could still navigate. It's counted as a regular click. Okay, so that's the first part of navigation. Now, Suppose I want to know this get full path is obviously from the path unit, and it takes a source path and gets the full path. If it's a relative path, it'll put the full path in the beginning. So if I right click on get full path, it's loading symbols, it's found it, it shows me the implementation. A lot of the library is written in Hopper. So it shows me what this method does. So I went to the source code in, if you look in the top right, path.hs under system. A little comment at the top tell me what this thing does. I can see the arguments, and I can actually just see the code of what it does as well. So if it's a relative path, it basically puts the current directory in front of it to get the full path. Let's go back, Control backspace. I could also right click on, so that was right clicking on get full path. If I right click on path, it takes me to the unit. So if I want to know what exists in the file unit here, I'm going to right click on file. Shows me all the methods that are available in the file unit. Most of them are system methods, which means they're implemented by the runtime, which is platform specific. It's implemented on the microcontroller one way and on Windows another way. Some are not. Some are implemented in Hopper source like this, like obviously a CLC, a 16-bit CLC calculation. And these will be the same on all platforms, the same implementation on all platforms. Anyway, Control backspace to go back again. Let's go and have a look at it a little bit more. Yeah, so it's not going to work as well as I'd like. There are some limitations. So it can't work with local variables. So it won't know what to do with that if I right click on this. And it won't know what that is, because it needs to know this type to know what that is. So it doesn't know, is this list append, or is this string append, or is this some user written append function? And it doesn't know because it doesn't know what that is. So the reason right click doesn't know is because that's a local variable. That's a nice trick too. If you double click to select a word, it's in dark gray, but other instances of the word are in light gray, so you can scroll around and see where some variables being used. So if you want to see where source folders is used, you can see where it's used, or where JSON path is used, like that. But again, it's not going to be able to find JSON path. Why? Let's find an example of what it will know how to find, and then I can explain. Yeah, so this source path, for example. So if I click on, if I right click on that, it goes to the definition of it. So down here, if I right click down here, if I right click on that, it jumps up to the definition here of the signature of the method and finds source path. So let's see if there's a method on source path somewhere. Is there one? No, there isn't. That's not very handy. Maybe we can find a better example. So also, if I right click on one of these built-in types like string, it'll take me to the string unit. So, right clicking on these, basically the blue words here. So right click on uint takes me to the uint. So what have we got here? Content. Are we doing something interesting with content? For the purposes of my demonstration, not really. Oh, we are. Okay. So here again, if I right click there, it's going to, so I'm over here. If I right click, it takes me up here to the signature. Now, if I right click on starts with, it takes me to the definition of starts with, which is also in the string unit. I'll Control backspace to go back to where I was. So I was over here. And so if I right click on the variable, it takes me to the definition. If I right click on this, it knows the type of this. So it knows the type is string, and therefore it needs to go to string starts with, which, so right now it's in the uint unit, if you look on the top right, or over here. So if I click on starts with, it takes me to string unit on the top right and starts with, because it knew what the type was. Okay, so how do you understand how this works? Well, I recently implemented this, and I used the intermediate file from the preprocessor to find the locations of definitions. And the preprocessor knows system-wide definitions, high-level definitions. The preprocessor does, you can think of it as everything outside the curly braces. So the preprocessor can't see into what the compiler compiles. The compiler compiles what's inside the curly braces. So that's why it knows what these arguments are, because they're part of the signature of a method which is done in the preprocessor. And so the only thing you can't right click on to go and find is these. Right. So is there another one I can show? Yes, maybe. Here, so I can also right click on defines, directive definitions. So if I right click on JSON Express, oh, it's not defined in the preprocessor. Interesting. It isn't. Okay. Let's edit the compiler. It's called compiler. There we go. So it is defined here. So if we go to symbols, JSON, look for it again. Here, if I right click on it, it should find it. It's loading symbols at the bottom here, and it jumps to where it's defined. And if I control back, I can go back to where I was. Control backspace, really handy. Anyway, yes, so if it's defined, it'll jump to its definition. Obviously, if it's not defined, there's no definition for it, so it couldn't jump to it. So when I was in the preprocessor, it couldn't jump to it. Anyway, I think that's about all the ways you can jump around source. Oh, yeah, another neat thing. Let's go and do a little bit CD samples, CD MCU, edit. Let's do blink, build blink. I've got a microcontroller hooked up, but you can't see it on the screen right now, but it doesn't matter. I'll launch this into the debugger. So bottom of the screen, it says it successfully uploaded blink to my microcontroller, and if I F5, I should see little pluses and minuses here, because it's on every loop, it's printing the state of the LED and a plus or a minus to the serial port. Okay, Control C. Right click on MCU. Loading symbols, definitions loaded. Let's do. Oh, sorry, double click on there, not right click. It went to. That was funny. Yeah, like right click's not going to do squat on there, but double click will go to MCU. So now if I do right click on PyPico, where's it defined? It takes me to here. And right click on LED, I go into the GPI opens here on the top right, and I can double click on blink to go back. I can also, if I'm in here, I can also double click on the stack trace here. So I'm now back in this getter for LED. It's a property to get the value of the current state of the LED. So if I double click on the right here on main, it'll take me back to where the line of code we're currently stuck on in the debugger in main. So let's step into here. There, okay. Yeah, that's better. Because now you can see with the right here to double click to go there, double click to go there. So that's another way you can get around, is by double clicking on the call stack. Pin mode, yeah, to definitions, again, same kind of thing. So just the same as the editor, because it really is just another version of the editor that's used for the debugger. So you can use the same navigation. Anyway, that's about all I can say about navigating in your project in the Hopper development environment on Windows. I'll leave a link to a playlist at the end of this to other tutorial videos, and another one for how to get started in like about 5 minutes on Windows. And I'll put a link in the bottom to where you get the releases from on my GitHub repo. Anyway, thank you for watching, and I look forward to your feedback.